Lesson 402, Chords and Arcs, Part 2. The objectives of this lesson is to find the degree measure and the length of an arc. You're going to use Chords and Arcs theorem and its converse. The only key term we have in this lesson is arc length, and it's part of the circumference of a circle. And here we're going to talk about the degree measure of an arc and that it's the same as the degree measure of its corresponding central angle. Okay, the blue line's representing your arc and the little red line down there is representing the measure of the angle. And so the measure of arc B, I went a little too far there. So the measure of arc BC equals the measure of angle BAC. And since I didn't type that on there, I better write it there. So I'm going to put here that the measure of arc BC, and it's a minor arc, so I only name it with 2 letters, equals the measure of angle BAC. I'll get it right in a minute. The degree measure of a major arc is 360 degrees minus the degree measure of the minor arc's central angle. Okay, so if you look down there at the bottom, it says the measure of the major arc BAC is going to equal 360 degrees minus the measure of the minor arc BC. Now we're going to look at the length of an arc. It says the formula for calculating the circumference or length of a circle is C equals 2 pi r, and r is for radius. So there, that yellow line you just saw go around, that was the length of the circle. Okay? And the formula for finding that length is C equals 2 pi r, where r is the radius. Now, to find the length of an arc, you're going to use this formula. It says to find the length L of an arc, you're going to use the circumference of a circle, the arc's degree measure, and the radius. So if M is the degree measure of the arc or the central angle and r is the radius, you solve the proportion shown here for L. So what we're looking at right here is here's our proportion. L over 2 pi r equals M over 360. And what they did, remember, we never like for that, we like to get rid of the denominator. And we're wanting to solve for the length, so we're going to get rid of this 2 pi r. And the way we do that is we multiply both sides of the equation by 2 pi r. And what happens is it actually reduces to 1 on the left side, so we're just left with L, like you see right here. And then we're going to multiply it on the right side. Okay, now then, let me write this down because this is an important question that you might be asked on a quiz or a test. What you need to know to find the length of an arc, you're going to need the circumference, it's a long word to spell, and remember that is C equals 2 pi r. Oh, ran out of room. I'll put it down here. C equals 2 pi r. That's one thing you're going to need. The other thing you're going to need is the arc's degree measure, and another thing you're going to need is the radius. Okay, I said we're going to be using the chords and arc theorem, and it's super simple. Okay, super simple. It says in a circle or in congruent circles, the arcs of congruent chords are congruent. So here's you an arc. You know what? Let me get my highlighter. Here's an arc, RS. Here's the chord, RS. Okay? Here's the segment DF. Here's the arc DF. So what this is telling us, I'm going to write this part out, is if RS, let me write this out right here. If RS is congruent to DF, then, I hope I have room to write it right here, then arc RS is going to be congruent to arc DF. There we go. I think that should be easy to understand. Now the converse of the chords and arc theorem says exactly the same thing but backwards. What it says is in a circle or in congruent circles, the chords of congruent arcs are congruent. Okay, so what all that is saying is, let's just write it backwards. It says if RS, arc RS, is congruent to arc DF, therefore segment RS is going to be congruent to segment DF. See? Just the same thing but backwards. So now let's look at some examples. It says, how long is the radius of this circle if the length of arc BC is 20 meters? I don't think that is supposed to be arc, is it? I think I even went back and looked. No, I remember now. They actually had it as a segment when it should have been the arc. There, I went and got myself confused and I already knew what was going on. Okay, so let's look here. Let's do some marking up. It says that the length of the arc is 20 meters. So here's our arc. And I just don't draw very good circles using this pad, to tell you the truth. That's 20 meters. Okay? And we want to know how long is the radius. And then you kind of look at it and you think, okay, how am I going to figure that out just knowing the length of an arc? Well, I want you to look here. The measure of angle BAC equals 90 degrees. Okay? And 90 degrees is a quarter of 360 degrees. I hope everybody agrees with that. If you take 360 and divide it by 4, you're going to get 90. Okay? So that means the measure of this arc, I'm going to say, let's put it right here. And I'm just writing this down in case I need it. I don't know yet if I'm going to need that information or not. Just writing down things. Okay, now then, another thing we know is that the length of BC is 1/4 or a quarter of the circumference. I gotta write out that long word again. I don't like writing out long words, in case y'all haven't noticed that. Okay, so if BC, if the measure of BC equals 20, and it's a fourth of the circumference, that means the circumference is going to equal 20 multiplied by 4. So that's going to give me 80 meters for their circumference. Okay, so now I want to find out what r is. Well, remember the formula for finding the circumference of a circle is 2 pi r. Now, I already know what the circumference is. I know it's 80. So I'm going to plug that in for C, the circumference. Now I'm going to divide both sides by 2 pi. 80 divided by 2 is going to give me 40. No. I think I just deleted everything I had written down. That's not good. At least y'all got it on the recording. So let's say circumference equals 2 pi r. We know the circumference is 80. And I got 2 pi r. So I'm going to divide, let's just go ahead and divide both sides by 2 to make that easier. 40, and then I have pi r. Then I'm going to divide both sides by pi. Now then, they didn't tell us to leave it in terms of pi or not, but I'm going to. Well, we can go ahead. You can either say the exact, let's put it like this. Remember, if we want our exact measure, then our radius is going to equal 40 over pi. If we want the approximate, hope you're remembering how this works, we put the squiggly lines, and 40 divided by pi is going to give me 12.7, approximately 12.7. Okay, let's go on to another example. There's the official answer that will be posted in Doc Sharing. Okay, it says circle D has a diameter of segment EF. Okay, the question they're asking is if the measure of angle GDF is 55 degrees, what is the measure of the arc EH? Okay, so GDF is right here. Just marking that up a little bit. They tell me it's 55 degrees. They want to know the measure of this arc right here, EH. Well, let's look at the figure for just a moment. If you look, EH, segment EH, is congruent to segment GF. And you remember the theorem, the Chords and Arcs theorem, says that if you have congruent chords, then their arcs are congruent. Okay, so if the measure of angle measure of angle GDF, I'm going to put that right here, angle of GDF equals 55 degrees, then the measure of arc GF is going to equal 55 degrees. The measure, oh no, I don't write it like that. EH is congruent to GF, therefore the measure of arc EH is going to be congruent to the measure of arc GF, and that's what we learned with that theorem. So what we just learned is that EH is going to be, well, you don't put the congruent symbol there, you put the equal sign, 55 degrees. So since GF is 55 degrees, I'll write it up here on my figure too, then EF is going to be 55 degrees. Hopefully that'll be pretty easy to grasp and remember. And there's the official answer. Okay, circle D has a diameter of EF, just like our last problem. It says if the measure of angle CDE is 120 degrees, and that's going to be this angle right here, what is the measure of the major arc EGC? So since we got a major arc, I'm not going to try to draw in the circle. EGC. Okay, that's how I determine my major arc. Okay, if you will remember, right at the beginning of the lesson, I said that I'm going to take the measure of, I'm trying to think of who I'm putting first. EGC is going to equal 360 degrees minus the measure of arc EHC. And that's a minor arc. I made it a major arc, but it's a minor arc. I don't want to confuse you by writing the wrong thing up there. Anything less than 180 is minor. So I'm going to put EC. So the measure of EGC is going to equal 360 minus 120, which is going to give me 240 degrees. And so that's going to be your answer. Okay, in this one it says the measure of arc EH is 43 degrees. What is the measure of the obtuse angle GDF? So when they're asking that, we're looking at this angle right here. So by the Chords and I must be thinking of the Lord of the Rings. By the Chords and Arcs theorem, the arcs of congruent chords in a circle are congruent. Okay, so that means this up here from G to F is also going to be 43 degrees. Okay, therefore the measure of the major arc GDF sorry about that. That means that the measure of arc GF equals 43 degrees, which means that the measure of the acute angle GDF is also 43 degrees. Okay? And let me put acute out here because that makes all the difference. Okay? Of GDF is going to equal 43 degrees. Well, the whole circle's 360. So if I say 360 minus the measure, and I'm going to put acute out here, angle GDF is going to equal the measure of obtuse angle GDF. So I'm going to have 360 minus 43, and when you do that calculation, you get 317 degrees. Okay, so these are just like when we did other lessons. You've just got a puzzle here, and you've got to piece things together. Okay, and that's just the official answer. What we learned in this lesson is the degree measure of a minor arc is the same as the measure of its central angle. The degree measure of a major arc is 360 degrees minus the measure of the central angle. The degree measure of a semicircle is 180 degrees. You can use a proportion to develop a formula for finding the length L of an arc. And in a circle or in congruent circles, the arcs of congruent chords are congruent. And also the chords of congruent arcs are congruent. When you get finished with this video, you need to be doing your LMS lesson 402 and complete the student guide, because remember, you get to use your notes in your textbook on your test, mid-unit and unit test. Read the lesson in the lesson guide to add to your notes if needed. Complete the following problems in the problem set. That would be 5, 7, 8, and 10. And contact me or attend TOGA if you have any questions before you complete the 402 quiz. And as always, make note of any general questions you may have for when you attend CC or CCO on Thursday. That's going to be it for this lesson. No, it's not. Please, please give me your course and section number with all communication. And now that's going to be the end of this lesson. Thanks for listening.